In this video, I'm going to show you how to create a trace plot for use in a free body diagram tool. So I'm running this analysis on a cantilever beam. I'm using some simple 1D beam elements fixed at one end with a vertical force on the other end. And I'm going to use an I-beam section. So a couple things that we need to make sure of for the output for the free body tool. In the load step, we need to request some specific outputs for use in other tools. So first of all, for the free body tool itself, we need grid point force. We need the forces and moments at each of the grid points. So we enable the GP force in the output file, and I specifically like to use the output2 or the OP2 format. We'll also need the L force. This is going to be used if you would like to contour the stress on the section itself of the I-beam. We have this ability in HM post to contour beam section stress. But in order to do that, we need the L force, the element force, and element moments in an OP2 format that has the correct vectors to then utilize this new tool. So once we've got those output requests and we've run our subcase, we can then import the results. So utilizing, and this is HyperWorks 2021.2, we'll go to the post and we're going to import the results. I'm going to go and grab this I-beam OP2, and that's going to open up a new browser, which is the result browser, and that'll verify the link of the model, the finite element model, and the results. So in the result browser, we can see we've got the OP2 load step 1, just the vertical force. So now I want to utilize in the post ribbon the trace plot. And essentially what a trace plot does is it's going to create cuts through the free body model that we want to extract these forces. In this case, the cantilever beam. So I'm going to go and enable the trace plot tool, and the dialog will pop up. And first thing we'll do is create this new group. Call this trace plot or FBD or whatever you want. And there's two main ways of doing this. We can select the node path, and that would be picking each individual node along the path. That's going to create a cut at every node. Or we can just pick the starting node and ending node and tell it how many cuts we want in between. In this case, I want to do a cut at every node. Pick our starting node. I'm going to hold down Alt. That's going to automatically select by path. You can see the icon next to my cursor has changed to a by path. And I've got my 11 cuts. Okay. And then my elements are going to be all my elements on my model. Node, I'm going to say 0 for number of cuts because in this case I'm utilizing the by path. So every node is a cut. And the cutting plane is normal to the node direction. Now, when I select my trace plot, select my simulation or my load step, I can orient this in whatever direction I want. And now I can go ahead and look at, let's look at force in the Y. Let's plot that direction in the Y. And you can see I've got a force of 10 applied, and my cut is going to show at each cut I have a section resultant of 10 at each of those cuts. And we can also do the moment about the Z. And here I've got my moment diagram going from 0 to 100. This entire length of this beam is 10 units. So in this case, we've got our force of 10 times our length of 10. So this is a nice visual representation of force and moment utilizing the trace plot. In this video, we're going to use the free body tool and the forces and moments we can extract from it to then plot a shear moment diagram in HyperGraph. We're going to utilize the trace plot tool. If you want more information on that, please refer to the trace plot video. We're going to take each of these sections that we created in the trace plot tool and then create a table from those forces and moments at each section cut. So the trace plot allows us to quickly create multiple sections to extract forces and moments for our plot. So we're going to exit the trace plot tool once we've created those sections, and we can go to force. When I open up the force, you can see I've already got all my free body sections. So I can select all of those because I want to create this full diagram. And I can go ahead and select the simulation. And then I need a summary table. With that summary table, we can see the summary table created in our model browser. It's simply a column data of our free body section with force values at every cut, at every position, and moments. Now, once this table has been created, I can go ahead and go to the free body dropdown and create a VMT plot file. I point to the summary table and save a new file. Once I've saved this new FBD file, it's a vmt.fbd, I can then open up a new page and change my client to HyperGraph line chart. What's nice is once I go to open the FBD file, I can change to Xsource and go and pick that new file. It automatically knows based on the type of file it is, the .fbd file, that all I have to do is go and point to this VMT subcase. The X is going to be my magnitude or my distance, and then my Y source is going to be my force and moment resultant. And I can either put each of these on one window or two windows and say plot. And here you can see my blue line is my force resultant, and it's 10 all the way across the distance, and my moment diagram from 100 at the grounded or fixed area to 0 at the application load. In this video, I'll demonstrate the new beam stress tool. It can be found in the HyperWorks HyperMesh post ribbon. A couple things are needed from the analysis output before you begin. In the output request, we need to make sure that we have element force, L force, to output the element forces and element moments in the OP2 format. When we have that analysis run, we can go to the post ribbon and go ahead and add that result to our HyperMesh session. And we can see our OP2 file here, and then in the post we go to beam stress. So what I ran was a 1D model with a section of an I-beam. So if we were to go to our traditional tools for contouring, we would only be getting contour on a 1D, and we would get the maximum of each of those 1Ds. But with the beam stress tool, we are able to visualize the contour stress through the section itself. So activate the beam stress tool and select your elements. We pick our subcase, and we can go ahead and plot either axial stress, shear stress, or von Mises. And we can go ahead and visualize those. So again, this is all within HM Hypermesh, so we can visualize our boundary conditions. So we've got a fixed constraint on one end and a force on the other. And you can see the von Mises through this section. We can go ahead and go to the advanced options and mesh mode. So it's creating a new contour based on coarseness or fine. So fine is going to go ahead and remesh that, do the calculation, and create a bit of a finer mesh. And we can also do a contour on element or nodal type. Nodal will give you a bit of a smoother result. So here we can see the von Mises going from the loaded end to the fixed end, and we can also switch between things like shear. So shear in the Y, shear in the Z, axial results, all on the section of a 1D element.